Section 9.2, Simplifying Square Roots. Now this lesson here is going to connect with two main things that are studied in the future. One we actually study in the next lesson, which is called the Pythagorean Theorem, one of my favorite theorems in the world, probably my favorite. The second concept that we'll connect with is the quadratic formula, which you'll come into later. It's mainly a good equation solving tool. But the way I want you to think about it as we go through this lesson, because we're only going to get a snippet of where it's going to be actually connected to some actual problems and solving, is I want you to think of this lesson where we simplify these square roots as a puzzle. That's the best way to come into it, kind of thinking about solving a puzzle, okay? And that might help you because that's really like a task. You're working through what you're given to get to an answer in the end. Okay, so first let's observe what it says right at the top. It says the square root of 4 times the square root of 16 on one side, and then the right side says the square root of 4 times 16, both underneath the radical symbol. So here they have their own symbol, here they're separated. Let's see how the answers compare. Square root of 4, well, we can take that, square root of 4 is 2, times the square root of 16, square root of 16 is 4. So I get 8 as my answer. Now, if they're both underneath the square root symbol, we learned we have to do what's underneath the square root symbol first. And that in this case, it's going to be a multiply. 4 times 16 is 64. The square root of 64 is 8. So we learned this cool new trick which says that it doesn't matter if you have your concepts or your terms, like a times b, both of them underneath the square root symbol, or if you have them separated into each having their own little square root symbol, either one is perfectly fine. So this is called the product property of square roots, and it just means, just like we did up here, so that you can reference up there, it means if we have two things being multiplied, not added, subtracted, divided, none of those, but multiplied together, two different terms, you can separate them both into their own little square root symbols. Now, I like calling them houses, so I'm going to call it that just for this lesson. If you hear me say separate them into their own little houses, that's kind of what it is, okay? So here's what we're going to do. We're going to be given square root symbols with big numbers in them most often. 180, 675, 63, 48. Some bigger numbers, you know. And we want to break them down as far as we can. We do not want to put these in our calculators. That was the last lesson. This lesson is not about approximating or rounding, because if the square root of 180, even though it's not on our list, we see that there's no square root of 180. So it's not a perfect square. It's not going to give us a nice even whole number. Instead, the square root of 180 is going to give us this decimal that goes on forever and ever and ever and doesn't repeat. It's 13.41640786499. It never stops. So we don't want a decimal because sometimes you're solving things and you can't, even if you round it, it's not going to work out to be perfect. And maybe that's not going to help you if you're working on like a big important engineering scientific experiment or project. So rounding isn't always the best way to go. Instead, we just want to simplify it. Simplifying again in math is like if you have 10 over 14. You don't want to leave it like this. That's no good. That's not good. We want to reduce it. We want to simplify it. Same here. We want to simplify these so they're not so big. We don't have such big numbers we're working with. We want the number inside or underneath the square root symbol to be as small as possible, and then anything else we just went out in the front like a regular number. Okay, so I know you're probably chomping at the bit to get going. Last thing, it says a radical expression is in simplest form. It's reduced, just like we know this is reduced because nothing goes into 5 and 7 as far as it can go. Here, it's reduced if you have nothing underneath the square root symbol that can be divided. That's what that first concept is saying. There's no fractions under the radical sign or under the square root. And there is no radical sign in the denominator. You don't have like 5 over the square root of 10. You can't have that. No square root under the denominator. You can't have 5 over 7 inside the square root. In the end, none of that's good. And here you can't have anything that can be simplified any further. Alright, so our job is to make sure in the end we have none of these cases, and then we're good. Example 1, square root of 180. So what I'm going to do is I'm going to go over here. I've made a list of our perfect squares, which you should have on a note card or something ready to work with. Even you should have them memorized, but even so, having them available to reference is going to help a lot. So square root of 180, that one's going to fall. We don't have a square root of 180. It's a perfect square, but it would fall right in that range. okay, between square root of 169 and 196. So it's going to be 13 point something. I already told you it's 13 point, I don't even remember, 13.4. We don't want to decimal, we don't want to round it, instead we want to break it apart. So what I'm going to go do is I'm going to have my calculator handy and I'm going to start dividing and seeing what can 180 be divided by? Which perfect square, working my way up the list, can I divide 180 by? That's going to give me a whole number. So I do 180 divided by 169. Nope, I get a decimal. 180 divided by 144. Nope, I get a decimal. 180 divided by 121. Nope. 100. No. How about 81? No. 64. No. 180 divided by 49. Nope. 180 divided by 36. Oh, there it works. 180 divided by 36 is 5. So that means instead of writing 180, I can write 36 times 5. All I did was rewrite it the same way. And people say, where did that 5 come from? 36 times 5 is 180. That's where it comes from. Okay, so I just divided by each of these perfect squares, the ones under the square root symbol, all the way up, until I find one that gives me a nice whole number like 5. 36 times 5 is 180. Now, I'm going to give them each their own little house. 36 gets its own little house, 5 gets its own little house. Square root of 36, we know that's a perfect square, it is 6. Square root of 5, nothing else goes into it. If I were to look at my list, 4 doesn't go into it, 1, we're done. There, you have your first simplified simplified radical expression. We're going to come back to B because it's a bigger number. Square root of 63, let's try this one out. So I'm going to go ahead and I want to see, that one might be too bright. I want to see what goes into 63. So I start, that would fall right in this range. I work my way up as this arrow is showing. 63 divided by 49, nope, decimal. 63 divided by 36, decimal. 63 divided by 25, decimal. 63 divided by 16, decimal. 63 divided by 9, aha, it works. So I can rewrite this as 9 times 7. I give them each their own little house. Square root of 9 goes away, it's now 3. Square root of 7, nothing goes into it, it's not a perfect square, that's as far as it can be divided. There's my answer. Now I want you to promise me something, that when you do these, that you don't jump ahead, okay? And here's what I mean by that. On square root of 48, use a different color. I want to break it apart and I want to see what goes into 48. Now I might say, oh, 4 does. 12 times 4 is 48. If you do that, if you don't work your way backwards and you don't get the largest perfect square that goes into it, you're going to be creating more work for yourself. So promise me that you're going to work through them, okay? So what I mean is, if you have the square root of 48, 48 would fall right in this range, right below 49. So between 36 and 49. So first I divide it by 36. And some of these you can do in your head. Obviously 36 does not go evenly without a decimal into 48. 48 divided by 25? Nope. 48 divided by 16? Oh, yes. 48 can be divided by 16. So I'm going to break this into 16 times 3. I give them each their own little home, their own little house. The square root of 16 is 4. The square root of 3 is 3. Okay? That is the easiest way to do it. Start with what you have and work backwards. Don't skip any, because if you skip it again, you're, in the end, yes, you can get the right answer, but you're going to be creating a little bit more work for yourself, and why do that? All right. Example 2. Now we're throwing some variables in. What we need to do first when we solve these oh, I'm sorry, we skipped letter B. I never came back to it. If you have a big number like 675, I'm only giving you, we're only going to be mainly working with the square roots up to 15, or 225, which are 15. Obviously, they keep going. You could do the next one, you know, get 16, 17, 18. What we're going to do, though, is stop here. So if you get a big number like 675, then just start with that. Start with the 225. So 675 would obviously fall in this range. So the first perfect square you can divide by is going to be 225. So we're going to clear my screen. 675 divided by 225. Oh, right off the bat, that one works, which is pretty nice. I get 225 times 3. They each get their own little house. Square root of 225 is 15. Square root of 3 is 3. So that's my answer there.